Hello friends, today we are discuss design of concrete structure. In last lecture we discussed about balance section, under reinforced section and over reinforced section. In this lecture we discuss calculation of moment resistance for balance section. So MU limit for balance section is 0.36 FCK B into XU max into D minus 0.42 XU max. And we know that the XU max, it depends upon grade of the steel. For Fe250, XU max value is 0.53D. So we put up XU max in this equation is equal to 0.53D. Then by solving this equation, we got MU limit for Fe250 is 0.149 FCK BD square. This is the MU limit for Fe250. Similarly, we can calculate for Fe415. For Fe415, XU max value is 0.48D. So we put up this XU max value in this equation and we got MU limit value is 0.138 FCK BD square. Similar manner, we calculate for Fe500. The XU max value for Fe500 is 0.46D and the MU limit for that Fe500 is 0.133 FCK BD square. This is the MU limits for balance section for different grade of the steel. Then we can calculate percentage of steel. Then percentage of steel calculate by equating C is equal to T. The C force is 0.36 FCK B into XU max is equal to 0.87 FY AST. We can calculate AST upon BD ratio, that is 0.36 FCK XU max upon D divided by 0.87 FY. Let us see problems on moment resistance of singly reinforced beam. Following steps are followed to calculate MR for singly reinforced beam. First of all, write down given. In the given material, that is FCK and FY, means grade of the steel and grade of the concrete, width B, depth, effective depth D and AST is given. And our find out is MR or MU. Then calculate actual XU. How to calculate actual XU? By equating C is equal to T. What is meant by C? That is 0.36 FCK B into XU is equal to 0.87 FY AST. In this total equation, unknown term is only XU. By equating this equation, we can calculate easily XU. That XU is equal to 0.87 FY AST divided by 0.36 FCK B. Then next, calculate XU max. Already learned in previous lecture, XU max depends upon grade of the steel. For Fe250, XU max value will be 0.53D. For Fe415, it will be 0.48D, and for Fe500 it is 0.46D. Then comparing with XU and XU max. First condition, XU is less than XU max, the section is under reinforced. Second condition, XU is equal to XU max, the section is balanced one. And third condition, XU is greater than XU max, the section is over reinforced. Now we discuss one problem. A singly reinforced RC beam has effective dimensions of 230 by 450 mm, is reinforced with 3 bars of 20 mm phi. Find the moment resistance of beam. Use M20 and Fe415. First, write down the given data. Width of the beam is 230 mm and then mention effective dimension of the beam. Means what? The depth is given, that is effective one. So small d is equal to 450 mm. That is effective depth. Then FCK is equal to 20 Newton per mm square. Fy is equal to 415 Newton per mm square. And they given AST, that is 3 bars of 20 mm phi. So we can calculate total AST is equal to 3 into area of 1 bar. So total AST is equal to 942.47 mm square. This is a sketch drawn. Then first step, to calculate actual XU. How to calculate actual XU? By equating C is equal to T. The C force is 0.36 FCK B into XU. T is equal to 0.87 Fy AST. Put up all values and calculate XU. XU is equal to 205.48 mm. Then we calculate XU max. We know that the XU max depends upon grade of the steel. For Fe415, the XU max value is 0.48D. So XU max value will be 216 mm. Compare XU and XU max. XU value is 205, XU max value is 216, means that XU is less than XU max. Then our conclusion is section is under-reinforced. When the section is under-reinforced, we know that our failure pattern occurs in steel, so our MU limit or MR value will be T into Z. Then what is the T? 0.87 Fy AST, and what is the Z? D minus 0.42 XU. So value of the MR is, by calculating this equation, the MR value is 123.82 into 10⁶ Newton mm. Now we see the design procedure for balance section. Once again I repeat, design procedure for balance section. For design for balance section follows the following steps. First, write down the given. In given, they are given load, that is MU or MR, and material. And we require to find out dimension of the beam, that is B and D, and area of the steel. So next step is assume width of the section. First of all, we want to assume somewhat width, that is 200 mm, 230 mm, 250 mm, or 300 mm. This is the first step. Then calculate effective depth. How to calculate effective depth? By equating MU limit. What is the MU limit? MU limit, once again we know that the MU limit depends upon grade of the steel. For Fe250, MU limit value is 0.149 FCK BD required square. Then for Fe415, MU limit value will be 0.138 FCK BD required square. And for Fe500, MU limit is equal to 0.133 FCK BD required square. By using this equation, calculate D required. Then next, calculate AST. How to calculate AST? By equating C is equal to T. What is the C force? 0.36 FCK B into XU is equal to 0.87 Fy AST. Now the XU value will be, XU is equal to that XU limit, and XU limit we know that the XU limit depends upon grade of the steel. Let us see one design problem. Design a singly RC balanced beam section for an applied moment of 60 kN. The width of beam 230 mm. Use M20 and Fe415. So first mention given data. Applied moment means what? The MU limit means factored moment. So we require that applied moment into factored moment. So factored moment is equal to applied moment into factor of safety, and factor of safety for load is 1.5. So factored moment is equal to 60 into 1.5 is equal to 90 kN, that is equal to 90 into 10⁶ Newton mm. FCK is equal to 20 Newton per mm square. Fy is equal to 415 Newton per mm square. Then next step will be calculate D required. The D required for Fe415, MU limit value will be 0.138 FCK BD required square. So MU limit is equal to 90 into 10⁶ is equal to 0.138. FCK value will be 20 and B will be 230. So in this equation, unknown term is D required. So calculate D required. By solving this equation, the D required value will be 376.53 mm. So round up this D required is equal to 380 mm. Then next step is calculate AST. The AST will be calculated by equating C is equal to T. That C force is equal to 0.36 FCK B into XU limit is equal to 0.87 Fy AST. We know that XU limit for balance section, once again it depends upon grade of the steel. For XU limit for Fe415 is 0.48 D. So XU limit value will be 182.4 mm. So put up this XU limit in this equation. In this total equation, unknown term is only AST. By solving this equation, calculate AST. The AST is equal to 836.60 mm square. So convert this AST into number of bars. Then how to calculate number of bars? AST divided by area of 1 bar. So provide 3 bars of 20 mm phi, the AST value, and this is the final solution. Width of the beam is 230 mm, effective depth is 380 mm, and provide 3 bars of 20 mm phi. This is the complete solution for design of singly reinforced balance section. Thank you.